All right, in this example, it's just sort of the opposite of what we did in the last example. In the last example, you were given an equation and you had to tell what the midline and amplitude was. Now in this one we're given a graph, and we can easily find out what the amplitude and midline are, and given what we know now, we can write the equation for the sine or cosine function. All right, so let's take a look at this first one. Now, it looks like our midline, it looks like our function goes from 0 to 8. So what's right in the middle is this -4. So I'm just going to draw in the midline at y equals -4, right? So we know that our midline is y equals -4. Okay, that should be a minus. All right. We can also figure out the amplitude. All right, it's just the distance from the midline to the peak. So in this case, the amplitude, the distance from 4 up to 0 is 4. Distance from, we can also measure it downward. The distance between the midline and the -8 is again 4. So our amplitude is equal to 4. All right, so now we can just write the equation as 4 times, now we had to also decide what kind of function does this look like. All right, now you know that sine starts at the midline and goes like that, starts and stops at the midline, right? Now cosine starts and stops at the peak, right? So this looks more like a cosine function. So this is just a cosine function that is vertically stretched by a factor of 4, right? So it's cosine of x, and then it's shifted down by 4. So we have a k of -4. Okay, so that's our equation. All right, so let's take a look at this next one. Now, here, let's see, we can see our midline, right? They've shown us the midline is y is equal to -1. All right, and our distance from the midline to the peak is between 1 and 0.5. So our amplitude is equal to 0.5, right? It's a distance from the midline to the peak. All right, so then we can just say midline is equal to y equals -1. I guess I don't need the equals, other equals. Let me erase that. And so now, so essentially our k is -1 and our amplitude is 0.5. Now again, we have to decide, does this look like a cosine or a sine function? So this looks like a cosine function, but it's not, it doesn't start and stop at the peak, right? We have something that starts and stops at the valley, right? Right? Because one cycle goes from here to here. So, so essentially it's the reflection of a cosine across, well, across in this case the midline, right? So it's a reflection. So it's actually going to be the negative cosine. Okay? So y is equal to -0.5 cosine, in this case our variable is x, and then it's shifted down by 1. Now you can always test this. If you're not sure, just put in some values for x and see if it's giving you what you want. So you put in 0 for x, right? Cosine of 0 is 1. So we end up with -0.5 times 1 minus 1, which gives us the -0.5. If we put in, say, pi over 2, cosine of pi over 2 is 0. So then this first term becomes 0 and we're at -1. If we put in pi, all right, cosine of pi is -1, so we have -0.5 times -1 becomes positive 0.5. Positive 0.5 plus 1 is negative 0.5, which is where we want to be. Okay, so you can always test it if you're not quite sure if you got the right function. But also keep in mind, we graph the sine and cosine functions, but also know that we can use a negative to flip it over. So if we so this is sine of theta, this is cosine of theta. This is negative cosine of theta, right? We could also graph the negative sine because we're just going to reflect it, and it would start, start and stop at the same points because it's just 0. But now we're just flipping everything over. So our positive values become negative, and our negative values become positive. So this is the graph of negative sine of theta. So you've got these 4 options for the basic functions. And then we're just going to either vertically stretch it or compress it, or or translate it in the vertical direction. All right, so I will meet you in the next video.